Welcome back! It's time for the first hands-on module of the course. In this video, we'll move beyond theory and get to work in a real coding environment. I highly encourage you to open Google Colab alongside this video and follow along with every step. We just wrapped up Module 7, where we explored the entire life cycle of data. Now, we're leveling up. Over the next 5 parts, we'll set up our environment, cover Python basics, and then dive into the libraries that make AI possible: NumPy, Pandas, and scikit-learn. Part 1 is all about getting you set up. We aren't doing any theory here. The goal is simply to get your coding environment ready to go so you can run your first line of Python without having to install anything on your local computer. Why are we using Python for this course? Simply put, it's the standard for AI work. It features readable syntax and a vast ecosystem of specialized libraries like TensorFlow and PyTorch, which we saw in earlier modules. Plus, it's designed to be approachable, so you don't need a CS degree to get started. To write this code, we'll use Google Colab. It's a free, cloud-based platform that runs entirely in your browser. There is nothing to install. It comes with the most important AI libraries, pre-installed, and even gives you free access to powerful hardware like GPUs for your larger projects. Getting started is easy. Just visit colab.research.google.com in your browser, sign in with any free Google account, click New Notebook, and you're in. You now have a blank, ready-to-use coding environment. Colab uses quite cells for your code. Type your code, then press Shift plus Enter to run it. Let's try it. Type print hello AI. When you run it, you'll see your very first piece of Python output immediately below. That's it. You've officially started coding. Now that you're set up, we move to Part 2, Python basics. We'll look at a small set of building blocks that serve as the foundation for nearly every piece of AI code you'll ever write. First, variables. Think of a variable as a named container for data. You assign a value to it, like age equals 25 feet or name equals Maya, and you can then reuse those labels anywhere in your code. Python handles different types of data automatically. Whether it's a whole number, a decimal, text, or a true or false Boolean value, you don't need to explicitly declare the type. Python identifies it for you on the fly. Next, we have lists, which let you hold multiple items in one variable. A crucial detail for beginners. Python uses zero-based indexing. This means the first item in your list is at index 0, not 1. Loops allow you to repeat a block of code for every item in a list. This is the underlying mechanic behind those phrases we used in modules 5 and 6, like repeating training across the entire dataset. Conditionals are how we implement logic. Using an if statement, the program makes decisions. For instance, checking if an age is 18 or older to determine if a user is an adult or a minor. Functions let you package logic into a reusable block. By defining a function once, you can call it repeatedly with different inputs, making your code significantly more efficient. Finally, let's put it all together. Here, we define a function that uses a conditional to check an age, and then we use a loop to process a whole list of ages. Notice how all these building blocks work together to turn raw data into a clear output. Moving on to Part 3, we introduce NumPy. It is the foundational library for large-scale, fast number crunching in Python, and is the layer upon which almost every other data science tool is built. Why does NumPy matter? It is essentially the bedrock of AI in Python. Libraries like Pandas, scikit-learn, and even heavyweights like TensorFlow and PyTorch rely on NumPy structures to function efficiently. NumPy's core object is the array. While regular Python lists are flexible, arrays are optimized for fast math. In this example, notice that multiplying a NumPy array by 2 performs the calculation on every number at once, something a standard list cannot do. Beyond basic math, NumPy provides built-in operations for common calculations, like finding the mean or the maximum value. These operations are not only convenient, but also highly optimized for speed. NumPy is fast because of vectorization, performing an operation on an entire array simultaneously rather than looping one item at a time. This is the exact same principle that makes GPUs so effective for training neural networks in parallel. In Part 4, we turn our attention to Pandas. If NumPy provides the foundation, Pandas provides the structure, acting as the standard toolkit for working with tabular data, rows, columns, and datasets. Pandas is the tool data scientists reach for first when starting a project. By building on top of NumPy, it provides a powerful, spreadsheet-like interface for your Python code, making data manipulation intuitive. The core of Pandas is the data frame. Think of it as a spreadsheet living directly in your code. Here we create a simple data frame with names and ages, and you can see how Pandas automatically structures it with labeled rows. This is where the data cleaning we discussed in Module 7 becomes practical. By using pd.read_csv, you can load real data files. The head function allows you to quickly inspect the first 5 rows to verify the data is loaded correctly. Pandas makes selecting and filtering data straightforward. Whether you want to extract a specific column like age, or filter for rows meeting specific criteria, the syntax remains clean and readable. Let's look at a quick workflow. We load a file, peek at the data, filter for customers over 40, and count them. It's a clean sequence of 4 operations that demonstrates how easy it is to handle large datasets. Finally, part 5 brings us to scikit-learn. This is where the machine learning concepts from our previous modules stop being just theory and become actual executable code in your hands. Scikit-learn is the go-to library for classical machine learning. It provides a cohesive framework for every stage of your model workflow, from preparing data to training and evaluation. Most models follow a standard 3-step pattern: creating the model, fitting it to training data, and finally using it to make predictions. This consistency makes it very approachable for beginners. In just 4 lines of code, you can define a decision tree, train it, and make predictions. The complex processes of training happen behind the scenes within Fit. We will build a complete, real-world example in the next module. Let's recap our toolkit. Each layer builds on the one before. Colab is your coding environment. Python is the language. NumPy handles your math. Pandas manages your data tables. And scikit-learn is your powerhouse for training and using actual AI models. Where should you go from here? Use free resources like Kaggle Learn or the official Python tutorial to keep practicing. My best advice for you is to manually retype every code example from this video into your own Colab notebook. Typing it builds real muscle memory that reading alone just cannot replicate. Let's bust a few myths. First, you don't need to be a math genius. Libraries handle the heavy lifting. Second, professionals don't memorize every bit of syntax. They look things up constantly. And third, you don't need a powerful computer. Colab works great on any standard laptop with a browser. It's time to check your progress. Pause the video and try to answer these 4 questions in your own words. What is the shortcut to run a cell? How are NumPy arrays different from lists? What does a data frame represent? And what are the 2 core steps in the scikit-learn workflow? I'll wait. Let's see how you did. To run a cell, use Shift+Enter. NumPy arrays allow for fast, element-wise math. A data frame is essentially a spreadsheet for your code. And finally, the core scikit-learn workflow uses .fit to train your model and .predict to make your predictions. Here is a quick vocabulary reference for you. Feel free to pause and take a screenshot of these terms. They are the building blocks we've covered, from variables and loops to vectorization and data frames. These are the foundations of all the AI work you will do moving forward. To wrap up, remember these takeaways. Python is our standard language, Colab is our free environment, and simple blocks like loops and variables drive everything. Use NumPy for math, Pandas for your tables, and scikit-learn for your models. You now have the exact toolkit used by professionals every single day. Up next is Module 9, building your first ML model. Now that your toolkit is fully prepped, we are going to use it for real. We'll load an actual dataset, train a complete machine learning model, and generate a real prediction. I'll see you there. Congratulations on finishing Module 8. Setting up your own coding environment and writing your first lines of code is a huge milestone. You have all the tools you need now, and I'm excited to see you use them in the next module.